Okay, let's start with some easy stuff. Just some simple square roots. We want to isolate the x squared there. So we want to get all the other terms on the other side. So we're going to subtract 3 to get that on the other side. Get 2x squared equals 8. Divide by 2, divide by 2. You get x squared equals 4. Take the square root of both sides. Don't forget to put plus or minus on one side because we're taking the square root of both sides. So we get x equals the plus or minus 2. We get two answers, 2 or negative 2. Here, same thing. You want to isolate that, so add 10 to both sides. Let's get 7x squared equals 35. Divide by 7. Get x squared equals. This is a little different just because it's not a nice perfect square over there. Take the square root of both sides. Don't forget plus or minus. You get x equals plus or minus square root of 5. And that doesn't really simplify there. Okay, step it up a little bit of a notch here. So if you have something like this, resist the urge to FOIL that. We could, and factor it, set it equals 0, factor it and solve, but it's going to be a lot easier if we just take the square root of both sides here. So if you do that on the left-hand side, you get x plus 3 equals plus or minus square root of 5. On the right-hand side, so we're going to solve for x. So I'm going to just put it in front. I like to do that. It's just easier here. So we get x equals negative 3 plus or minus square root of 5. Same thing on this one. We're going to take the square root of both sides. We get x minus 2 equals, I'll leave a little room there because I'm about to put the 2 there. I'm going to add 2 to both sides. So 2 plus that. Get x equals 2 plus or minus square root of 3. Those aren't bad. If you get something of this form like this, you don't even have to write down the steps. I'm just going to take square root of both sides. You get x plus 1 equals plus or minus square root of 4, which is 2. Subtract 1 from both sides. You get that. That's actually two different answers. I want to make sure you know what you're doing here. So this would be negative 1 plus 2, which is 1, and negative 1 minus 2, which is negative 3. So we get two answers for x. X equals 1 or negative 3. So if you can get things like a perfect square on the left-hand side, like a binomial squared, and just a number on the right, even if it's not prime, it works out just fine. So this is the second time we've seen complete the square. Let's start with an easy one, and eventually we'll get to the more difficult case here. So let's start with the easy case here. This is when that middle term's even, it's not too bad. So first step, you have to do this. This is very important. Either way you do, always start by, in this case, you want to add 12 to both sides. Right, so x squared minus 4x equals 12. Leading coefficient must be 1. If not, you need to divide each term by the leading coefficient. By the lead coefficient, I call it A sometimes, but by the leading coefficient. In this case, the leading coefficient is 1, so we're cool with that step. You skip it. This is that weird step we talked about the other day, where you have to take half that middle term and square it and add it to both sides. So we're going to figure out what value here makes this a perfect square. So we're going to add half of the middle term. So half of 4 is 2. 2 squared is 4. So I took half that term and squared it, and I added it to both sides. To be fair, you have to add the same amount to both sides. Okay, so simplify and factor. The left-hand side should be, the reason we did this is it'll be a perfect square. So x, this is a minus sign right there, so it's going to be minus. The square root of 4 is 2, so it's got to be that. 12 plus 4 is 16. Simplify and factor, right? At this point, you're really done with complete the square, essentially. This is kind of like we talked about a minute ago. If you can get it to something that looks like that, you don't even need directions at this point. You just go, okay, take the square root of both sides. Simplify that. X minus 2 equals plus or minus 4. Add 2 to both sides. Get x equals 2 plus 4, which is 6, and 2 minus 4, which is negative 2. So we get two answers. That's your basic complete the square problem. Are you ready for the tough stuff? Here we go. Okay. By the way, why don't we just factor this, right? Surely we could factor that, right? Factors of -10, do the AC method. They add up to 6. 5 and 2 don't add to 6. 10 and 1 don't add to 6. We can't factor this. So there are some problems that you could say could not factor. I can't do it. We don't know how to do it. So complete the square works on all these problems. Does it get a little messy? Yes. Is it involve some fractions sometimes? Yes. But can you do it? Absolutely you can. So let's go through the steps. The first step, very important, you start with this. You want to add 5. You want to get the constant over to the other side before you do anything. So you get 2x squared plus 6x equals 5. Now, the next step is we skipped last time, but we actually have to do this time. So the next step was to divide every term by the leading coefficient. If that coefficient is not 1, it's not. You're going to divide every term by 2. So, and I would divide each term, not the whole side, just each term. It's going to be much easier to cancel, simplify if you do it that way. So the first term, oh, I like that. Now it's just nice. So this isn't too bad, so 3x. I'm leaving a blank for what I'm going to do. I'm going to add a term there, and this is going to be a fraction 5/2 plus some term here. Okay, so this is where it gets a little dicey because this is an odd number. It's a little bit more work. So that step was a little bit tough, but now we've got a fraction in here. So I'm going to take half that number. So off to the side, I'm going to do half of 3. I know half of 3 is 1.5, but I prefer to write it like this. Half of 3 is 3 divided by 2. It's a fraction. We really prefer improper fractions. They're easier to work with. Because I don't know what 1.5 squared is, right? So, but 3/2 squared, I can do that. So you're going to square that half of that term. So to square that, you go 3 squared is 9. So that's a 9 up top. Really messy 9. And then 2 squared is 4. So 9/4. So you can add 9/4 to both sides. So add 9/4 to both sides. And so you're going to get, let's see, this should be a perfect square. So I mean, you're trusting it is. So you go in x, this is plus, so it's got to be plus. The square root of 9/4, we just kind of did that over here. It's 3/2. So it's always just the square root of that number when you do this complete square method. In order to add these two fractions together, I need the same denominator. So I'm going to multiply the left-hand side of the left-hand term by 2/2. So I have the same denominator, 4. So now I have 10/4 plus 9/4, which is 19/4. Now you're going to take the square root of both sides, because this is that form we kind of like, right? This is, we can deal with this. This is got some fractions in there, but it's not too bad. So we get x plus 3/2 equals plus or minus. I'm going to separate this out so that the numerator is definitely square root of 19, but the square root of 4, because both of these are under the square root, the square root of 4 is actually 2. And I like that because now the denominators are the same. Those two fractions might add up really nicely here. So I'm going to subtract 3/2. I like to put that at the beginning here. So that I get x equals, and you can write it like this. This is perfectly acceptable for me. You can also write it as one big fraction. So you could write it as -3 plus or minus square root of 19 all over 2. So either way is acceptable there. So you can write it in either form, but that's, you're done with complete square. And you can see that's not an answer we're going to get from factoring, right? That's a pretty intense answer there for a pretty intense problem. So we're stepping up a notch. So let's try another one. Let's try just with a negative. That just adds a little twist, right? So let's see what happens. Oh, this one is a little twist on the problem. So it says rewrite in vertex form. So this is just a slightly different version of complete the square. Some of the steps are exactly the same. So the first step, move the constant over. You're going to do that first. So I'm going to subtract 3 from both sides. So I get y minus 3 equals -x squared minus 2x. So the second step is a little different. So instead of dividing by the leading coefficient, I'm going to factor out. When I'm putting this in vertex form, I'm going to factor out the leading coefficient, the lead coefficient. Get some music there. Okay, so whatever the leading coefficient is, in this case, the leading coefficient is -1, right? So that's our leading coefficient. So I'm going to factor that out. So I get y minus 3 equals -1 times x. I'm taking out a negative, so this is going to be plus 2x plus blank. I'm going to add something to both sides, so plus blank over there as well. This is where you have to be really careful. So I have to add the right amount here. So you take half that middle term squared. So half of 2 is 1. 1 squared is 1. So I'm going to add 1 to the right-hand side. Now, because this is being multiplied by -1, I didn't really add 1 to the right-hand side. I really subtracted 1. So I'm going to subtract 1 on the left-hand side as well. So that term that you took out, that you factored out, is going to affect how much you add or subtract to the other side here. Okay, so we get y minus 4, we're almost there, equals negative. This should be a perfect square now. So this is going to be x and plus, because it's a plus, square root of 1 is 1, so it's going to be x plus 1, quantity squared. Last step is you move the constant back over, right? So you're going to add 4 to both sides. So you're adding 4. And now we have vertex form. Y equals negative. You can probably identify your h and k, right? If you want to identify h and k. -1 is your h, 4 is your k. This graph is going to open downwards because it's got a -1 in front. So it's going to reflect over the x-axis. That's your vertex form equation, and you've got it. Okay, let's put it all together here with this one. Again, we're getting progressively more difficult. Again, this one we're doing vertex form, so we're not going to divide. We're going to factor out that leading coefficient when we get there. First step, always just move the constant over. We're going to subtract 5 first. So we get y minus 5 equals 2x squared minus 4x. You're going to factor out the leading coefficient of 2. So you get y minus 5 equals 2 times x squared minus, I guess, factor out of 2, so 2x plus blank plus blank. I'm going to add something to both sides there. Okay, so half of this middle term, half of 2 is 1, -1. -1 squared is +1, so I'm going to add 1 to that side. Remember, because of this leading coefficient, I'm not really just adding 1 to the right-hand side. I effectively added 2. So I've got to add 2 to this side to be fair, to balance out the equation. So I get y minus 3 equals 2 times, this should be a perfect square. That's a minus, so put minus. The square root of 1 is 1, so it's 1. Last step, add that constant back over, or just move it over, subtract or add it, whatever you need to do. And you've got your vertex form equation. If you want to identify your h and k here, h is +1, k is 3. This parabola is being stretched, so it's kind of skinny, but it opens up because it's got a 2 there in front. You could graph it at that point if you needed to. So this is a really elegant way of putting our equations in the right form that we want them, either solving them or putting them in vertex form.